The galleys are a very important part of a laboratory space in the facility. They have two main functions. One is they are the spot that all of the utilities for the building run through. So that gives us a very easy place to access those utilities. All of our utilities are teed, valved, and capped if they're not run into a laboratory, so it's very easy to attach onto that line and run a new utility into a laboratory that wasn't previously needed there. And that galley space makes it very easy to do that without interrupting what's going on in the laboratory itself. As you well know, nanotechnology is changing very, very rapidly, so the probability of us having to change out equipment or modify equipment in the laboratories, which cause new utilities or modifications of the existing utilities, is very high. The other important function of the galleys is that it's a place where we can put things that might interfere with the experiments going on, such as vacuum pumps and chillers that'll create vibration, acoustic noise, that kind of thing. That isolates them from the laboratory so we don't get that kind of acoustical contamination or vibration contamination in the lab. The subfab is the area below the clean room. Clean rooms are also called fabrication facilities, or fab for short, so the subfab is the below fab area. One of the important factors of a subfab is it is not in the clean air path. The air goes through the clean room floor, but there's another layer of decking below that. That's a concrete, what we call a waffle slab. The air goes below the clean room floor, but above the waffle slab, so the subfab is completely isolated from the clean room itself. That allows us to put things that are less clean down in the subfab. Again, vacuum pumps, chillers, as well as gas cabinets for inert gases. All of these can be located down in the subfab. First of all, it keeps them out of the airflow path, but also the clean room space is very valuable. So the subfab is much less costly space, and we can put a lot of these ancillary functions down there, run the piping or the wiring up into the clean room itself. The subfab allows us to make changes. All of our utilities are routed down there, and it allows us to make changes in utilities going to equipment, add new equipment in, things like that. So it's a very useful space that is isolated from the clean room, but very accessible to the clean room. Okay, we have air handlers up above the clean room. Very important thing, as I had mentioned, to keep a lot of airflow going through the clean room. So we have makeup air systems where the air comes in from the outside. It goes through several levels of treatment before it becomes clean enough to go into our airstream. It also undergoes temperature and humidity modifications, and then goes into what we call the recirculated air handlers. So it passes through them before it actually gets to the clean room itself. The recirculating air handlers have filtration, fans, and sensible cooling. In other words, it senses the temperature inside the clean room and adjusts the cooling according to that. You don't need to add any heat to the air because the friction of moving that air through the ducts adds plenty of heat. So by controlling the cooling rate of the air in there, we can control temperature stability very, very carefully. This air then flows down through the clean room, under the floor, back up through the chase, and back into that recirculating air handler. About 10% of the air in the clean room comes in through the makeup air system, and 90% of that air is recirculated. We're actually using ULPA filters rather than HEPA filters. An ULPA filter, ULPA stands for ultra low penetration air filter. A HEPA filter is 99.97% efficient on a 300 nanometer particle. An ULPA filter is 99.999% efficient on a 100 nanometer particle. So a much more efficient filter that's used in this facility to keep the facility so clean. There are, again, two good reasons for using a bay chase design in a research clean room such as ours. One of those reasons is it makes the facility more green. It cuts down on your air handling costs very significantly because you only have to treat the air that's going into the bays, not the chases. And that makes up about half the clean room. So you cut your utility cost essentially in half by just treating that air that's going through the bays. In addition to that, being that the bays are smaller, it's easier to keep the bays very, very clean. So you can actually approach mini environment cleanliness using a bay chase design if it's properly designed. So that's one really good reason to use bay chase. The other reason is we put the mass of the equipment back in the chases Again, that helps from a cost standpoint, but the big thing there is the people who are working on the equipment are the only ones allowed in the chases. So what we're doing by using a bay chase design with the mass of the equipment, the repair side, in the chase, protects the equipment from people turning the wrong knob, something like that. Where in the clean room, the bay area of the clean room is the only place that research materials are exposed. So they're only exposed in the cleanest area of the clean room.